Never been a big fan of heights, but heights does make me think of formulas, and it does make me wonder how far up this little cliff is here at Lighthouse Beach. I guess that makes me think there's a formula that may be able to use to test it. I'm going to try that right now by throwing a rock over the edge. Now don't try this at home. I'll check carefully to make sure there's no one else around. I'm on my own. It's embarrassing otherwise. So here we go. We'll see if we can throw this rock down. Okay, what we might try and do is get the time for that and then see if we can calculate the height. Okay, so we're looking at formulas. This is the formula we're going to use to calculate the height of that little lookout there at Lighthouse. This S here stands for the distance, in our case it's the height. A, we know, is 9.8. Now that's acceleration due to gravity. We don't need to know that now, it's given to us. And in our questions we'll be given certain information, and we know our T from the video. Now I've had a look at the video a couple of times. I reckon it's just over 2 seconds. I'm going to get 2.2. Could be wrong, but that's what I'm taking anyway. So S is a half AT squared is the formula. Distance is a half A times time squared. Now this S here, whatever's at the start here of formula is called the subject. So this is the subject of the formula. And that's what we want to calculate at the moment, the subject. It's just a matter of substituting the numbers in. So you get S is equal to 1/2 times 9.8 times 2.2, and that's squared. So we're just replacing the pronumerals with the numerical values we have for them. Jump to your calculator, pretty simple. S is equal to 23.7. So on my calculations, that is the height of the cliff above the sea. So there's lots of different formulas. Another formula we have that relates heights is the distance to the horizon formula. And one of these formulas is D is equal to 3.5 square root of H. And this formula will tell you how far the distance to the horizon from a particular height. Now if we knew in our previous video that the distance to the horizon was equal to, say, 14 kilometres, that's how far we could see from that lookout, then we could use this information to calculate the height a different way. So at this time now we're going to substitute this information and see if we can come back to our height. In this case, the subject, remember this is what we call the subject, whatever's at the start of the formula. So D is the subject, but D is in fact the distance. So this time we've got 14 is equal to 3.5 root H. So now to find out my height, I'm going to have to solve an equation this time. So we'll use our inverse operations. I want to remove this 3.5. It's times the root of H, so I'll divide both sides by 3.5. I'll get that answer. And that will leave me with 4 is equal to the square root of H. Now I want to find H, and we haven't done many, if any, equations like this. I need to reverse this square. To do that, I'm going to take the inverse operation of square root, which is to square it. So H is equal to 4 squared. In other words, H is equal to 16. So the distance will be in kilometres, the height will be in metres. So in other words, using this information, if the distance is 14 kilometres to the horizon, I'll be 16 metres high. Okay, so lots of different formulas. This one, volume, is 4/3 pi r cubed. What I want to do here is I want to calculate the radius of my tasty looking apple. To do that, I need to calculate the volume. So I'm going to do that using Archimedes' principle, and I'm going to submerge the apple in this measuring jug. I don't think you can quite see that. It's about 250 mils in that jug. I'll put the apple in. I'll just push it down, and we'll see it gets up to about 450 mils. So the apple has made the water increase by 200 mils. That tells me the apple's volume is equivalent to the amount of water it's displaced. So 200 millilitres means that it's actually 200 centimetres cubed. 1 millilitre is a centimetre cubed. So now what I can do, I can use this formula over here to calculate the radius. So my volume is the subject of the equation. I'll put 200, that's what I know it is 4/3 pi r cubed. Now I want to calculate r in this case. To do that, solve this equation. Times both sides by 3 to get 3 off the denominator. I get 600 is equal to 4 pi r cubed. Now I want to get r on its own. It's got a 4 and a pi in front. I can actually divide by both of those at once. That way they're both gone. And 600 divided by 4 pi on a calculator, you'll find that's about 47.7. And that's my radius cubed. Now the inverse of cubed will be the cube root. So to work out r, I need to take the cube root of this number, 47.7. I'll plug it in my calculator. I'll calculate it out. 3.62, that's r equals, 3.62 centimetres. So my rather tasty looking apple over here has a radius of about 3.62 centimetres. Lots of assumptions there, first one being that it is a perfect sphere, but that's a couple of different formulas and substitutions. You can see it's just like solving equations. You just have to put the numbers in, then go ahead and use your inverse operations.